Yeah, so sorry. Could you please repeat it again?
Yeah, so I was saying that when a user has an app open, we are constantly sending the request, or the user is reading.
That's a good question. So usually what will happen, see, the first time when he opens, so he will actually try to find all the drivers which are located nearby. So that is the first time he pulls the requirement from the server or request from the server. So that is one thing, but we have 1 million such users. Okay,
And
so
and
initially,
and as long as the app is open, we are constantly sending the updated request. So the app has to keep on it can be a long pulling, right? But it still be pulling, and it will be an API request, right? Then HTTPS request going to the server. So will he
yeah,
calculate that as in the read QPS?
yeah, because so what happens, when the ride is actually going on, so both the driver and the customer, they will be informed about their status location always continuously. So that is where the read QPS comes in. So therefore, it has to, even if he books a particular driver, and then when they are going ahead in the whole ride, so every time either the driver is sending his location, so that location will be also communicated with the client. And therefore, that will be that is what the read QPS comes in.
But
That is what
that
I
be a
think.
part of the calculation of read QPS, because right now we are saying 1 million, right? And we have 1 million daily active customers. So we are expecting that they are making one read request every time, or maybe 1 million daily rides, right? But for every ride, there'll be a lot of reads.
Yeah, so you are saying the read QPS might be more higher.
Yeah. I mean, if that is how, like, again, we can ask the interviewer how he wants us to calculate this, but I feel that should be a part of, because it is hitting our system for a read, right?
Yeah. So that is true. But the major portion is whenever he logs in, at that time he's actually pulling the information from the server, and that is the first time actually he gets the information. And after that actually he is notified. So I don't know whether we should call that as a part of the QPS also. So yeah, that might be what you say makes sense. It's always better to get it clarified. Absolutely, you're right. So maybe the reading QPS, whatever is shown here, is very low. It might be more. That is what you're coming up with, right?
Yes.
Yeah. Okay. Fair point.
Yeah, hi
So.
Santosh.
Mm-hmm,
So I have one question.
mm-hmm.
So you have estimated the right QPS. So the estimation is 500K divided by 3. It should be 500K divided by like 86,400 second divided by 3. No? So we have daily 86,400 second in a day. Okay.
Okay.
So the
So.
calculation. Huh?
So the way it is,
So the
we have 500. Yeah, I had that doubt. I was also thinking about it, why it is like this. But the way I came up, let me explain what the way I came up. Then we can discuss that. So I'm saying, 500K daily active drivers is our estimation figure, and then all the active drivers notify their location every 3 seconds. So all these 500K actually are, informing the server their location after every 3 seconds. So that is the reason I took 500K by 3. But what you say also makes sense, because earlier I was going by that way. So you are saying 500K divided by 3 into 86,400, something like that, right?
yes.
I don't
But
know,
I
but
think for every 3 seconds interval, what is your write request will go, right? So it makes sense 500K by 3 only, right?
that is the way I came. But initially, I also had the same what Faiz was discussing now. I don't know, but it might be a thing to explore more. So this is the way I came up with. Yeah, I thought like 5,000K daily active user every time they're actually informing the server every 3 seconds, just divided by 3. That might be one way of doing it. But
No,
if
but
you
that
say
divided by 3 looks more like you're dividing the number of daily active drivers by 3. Oh, so you're saying daily active drivers are okay.
yeah, because the driver has to continuously send his location.
True,
And
true.
Mhm.
So how many? So the calculation should be on how many parts we can divide the number of seconds in a day in a triplet, like in a pace of 3, like 3 seconds, 3 seconds, 3 seconds, right? So that many times per day, 500K drivers are sending requests, right?
Mhm.
So it should be 500K into 86400 divided by 3, right?
So the driver will work for around 8 to 9 hours daily, na? So we can consider that part
True, true, true.
instead of.
We can reduce it. Yeah, true. We can reduce it to that. But it will be way higher than I would think 166K if we take that into consideration.
Will be a way lower, I guess.
Lower?
Yeah,
Yes.
because denominator will increase now.
So what he's saying is 500K, assuming by 3 seconds. Now it's happening like we are doing it for 24 hours. But is it not, we have a very small focus already, like we have 500,000 drivers, and every time, because in some cases across the globe is going to be right, so somewhere or the other drivers are always going to send a request per 3 seconds.
Yeah, so we can understand in this way, Santosh. So suppose I am a driver, okay, and I am online, okay. So in every 3 seconds, if I am sending a request now, so in every 60 seconds, I am sending 20 requests.
Okay.
Okay. So if you multiply it with that time now, how many like we have 10 hours in a day. Okay. So we have to multiply that part. So we are like losing this. So yeah.
So you are saying like 500K multiplied by 20. This will be per minute, right? These many requests per minute they are going, isn't it? Then
Yes.
if you
And
add
multiply by 8.
8,
Yeah.
yeah,
Multiply by 24. Yeah. Something
yeah.
like that.
So if we just multiply by 8, so it'll be an hour, one shift. So if we get this, so this amount will be almost a right request per day, you can say, isn't it?
Yes.
Okay, so you are saying the right QPS also will be very high. Makes sense.
Hey, hi, Ram here. This is my first day, so I'd like to just understand this. So 8,086,400 is total seconds per day, right? So just divide that by 3 should give you like number of 3 seconds, right?
Yeah, true. But we are saying that drivers are not going to work for the whole day.
But it is the whole system, right? It's not the driver. It's the whole system that is going to accept this number of requests.
Yeah, there might be another driver.
It's not a single driver system, right?
True.
Cool. So I think it makes sense to just divide 86,400 divided by 3.
Yeah.
That many requests is going to come.
From 500K drivers, right?
So 500K divided by this whatever number should give you the QPS.
Okay, so what it comes to as per you, Ram? So you are saying, okay, this is what
it comes to 17.36.
Yes, approximately
36. Okay, so but
I mean this is on a normal traffic. It's always not uniform as you consider like 500K. It's at the max peak.
Okay, so you are saying 86,400 divided by 3.
Yes, and 500K divided by this number.
And then this number should be divided by 500K. Like this?
Yes.
Okay. So then what we are doing is we are taking the days, seconds, and then dividing by 3. Okay.
Yes. So for every 3 seconds.
And then we are dividing that number.
Can someone explain why we are dividing?
Yeah, it doesn't.
First,
It's not
What
making
about
bit sense. You are already bringing it to seconds per sec by dividing by
because
86.
the way I look at it, all active drivers are sending the location every 3 seconds, right?
So we are not updating the location in every second. Na? We are updating it
yeah,
after every 3 seconds.
after
That's
every
why
three
we are
seconds?
dividing it by 3.
Yeah,
Okay.
but dividing by
Exactly.
8640 is like you already bought it into seconds, right? Bought it down to seconds
So
per
that is
second.
for whole day total seconds, but you're not sending the request every second, right? You're sending only for 3 seconds,
Okay.
every 3 seconds.
Every interval of 3. Okay. Yeah. Makes sense.
And usually, like I keep it like 100K just to be a lot easier with calculations, if that helps.
yeah, the 86400. Yeah.
Yeah.
So what about if we take some percentage of the active user in a given point of time? So like out of 500K, so 50% are active.
So
Basically, here we are calculating the QPS. Na? So I don't think so. We have to go that way. So actually, we are trying to find out the query per second per write.
Yeah, so we are
Yeah.
calculating the QPS. So let's say 50% active. So we calculate the QPS for those, and those 50% will active throughout the day. Some will go, some new driver will come.
So you are saying, Praveen, like take this 500K and then divide by 50, half.
Like half, yeah.
So
Yeah.
250K drivers. Is it?
Yeah. So sorry to interrupt you. So as you can see in the estimation, there are 1 million daily active users. Sorry, 1 million. Sorry.
Those are the customers.
But the
500K
rights
is the
will be
daily
for the
active user.
customers as well, no?
Yeah, but
Yes,
the more prominent right is from the
Will be
drivers.
from the drivers.
Yeah.
Okay.
So the customers are, but they actually only do it for once for the requesting the right, and then after that, actually, it is the driver the right requests more. And why it is, we'll come to that later. Okay, no worries. So we'll just park a discussion here because yeah.
You can, and my tip here is that, I mean, don't spend too much time on that.
Absolutely, yeah. No, we are just trying to understand because I was also confused the way I took it here.
500K, that should be fine.
Okay, no problem. So the API is what will be discussed here today is like on this request write, find nearby drivers. So both of these will be from the customer, and the update location will be only from the driver. So this is a high level diagram. In this case, you have customers requesting a ride. This request, as well as the find nearby driver, goes to the load balancer, and then it goes to an aggregation server. And from an aggregation server, it goes to a query. So here, what we are doing is we are taking the same design what we discussed for Yelp, that is a query one, and then we are trying to see if it fits. And if it doesn't fit, then what things have to be modified. So basically, the whole discussion is around that. So what we discussed for Yelp about the query, it was a dynamic grid, and there the updation of the locations was not very frequent. So that is the only difference here. In this case, what will happen is the query are nearby locations, or maybe the point of interest are the drivers, right? And in this, in here, the drivers are frequently updating their locations because they are always moving. So therefore, we have to actually change the driver locations every time in that query grid. So that is some challenge, and we'll discuss that about how it is done here. So the request ride flow is because the request ride flow is like the customer puts a request for the ride, okay, and then one of the aggregator server will take this request and pass it to the query server, and the aggregator server collects the results from the query, which is written from the query server. So we know how it returns from the query server, right? Actually, when it goes to query server, it will go down to the lower level of that leaf of that query, wherein it will find the location of the driver, and then it will try to have a radius around that place, and then it will find all the locations of the drivers for this particular customer, and then all of that will be aggregated by that aggregator server, and then it will be notified to the customer about the list of the maybe first top 10 drivers or so. And then then actually the customer will accept one of the drivers, so that will be notified, that first driver will be notified and assigned to the rider if the driver accepts. Or if it isn't, then okay, and other case, if initially what it will do, it will send a set of maybe 10, a list of 10 drivers for that particular customer. And out of the first 3, if the customer picks up any one of them, that driver will be assigned to that for that ride, and the others will receive a cancellation request. And if those 3 don't respond, then the actually system will go and actually send a request for the next 3. So if any one of them respond in that 3, then they will be assigned, or else it will keep doing it for till the list is exhausted. And if none of them respond, then it says at the last that no one is responding for the customer. So that is what will be notified to the customer. So this is what the request ride flow is. So the other things about finding nearby drivers is just a call, and it will go to the aggregation server, and then in the quad tree, it will go again do the same thing. It will find whatever the least based on the customer's location. It will go to that particular grid and get all the information, and then it will again form a list and then return back. And for the drivers, it is just going to update his location based on his driver ID and the latitude longitudes. So that is the only simple flow for the other 2 APIs. Okay, so any questions till now on this?
Can we discuss a little bit about how the quad tree structure will be? Will it be like, is it a key value thing? Or it just like it's a node, and the node will have the driver ID and the lat long?
Yeah, so the way the quad tree we discussed for the Yelp, it will have the root grid, and then it will be divided into another 4 childrens based on the number of drivers in each and every grid. And we are actually assuming here again, if there are more than 500 drivers in a particular grid, then we are going to divide it into another 4 parts. So we'll keep dividing that. Okay. So that is the way it will be. And at the leaf ends, we'll have at least 500 drivers per grid, and all the 4 those leaves will be connected by a doubly linked list. Okay, so that is the way it will be. And every time whenever a driver updates, then it will actually, sometimes it will have to move from one grid to another also. Okay, so this is what actually is being discussed in this, what they say, it's similar solution of Yelp, which uses a quad tree. And but Yelp, in the Yelp, it was not designed to update the places of interest very frequently, but here we have to. Okay, so then how this can be done? So yeah, at the leaf node, we are actually going to store the driver's location. So it will be the latitude, longitude along with the driver ID. So that is the way it is. But if you see, there will be too much of write requests going to the grid. And every time we are updating that grid, there will be many writes in the grid. And the quad tree also will be so dynamic, it will keep on frequently changing. So we'll have to always partition it, and also we'll have to repartition or the quad tree, and in some cases we'll have to merge also, right? So there will be a lot of dynamism in the quad tree. So how can we do that? Because what is said is the active drivers, they report their location every 3 seconds. So then we could actually limit that 3-second request. And what we can do is we could actually only inform the system after every 15 seconds. So we could store the rest of the data which we get for every 3 seconds somewhere else, and only inform the system after 15 seconds. So that is some limit we can do, and therefore it will actually have a less burden on our quad tree, because we are not consuming more resources if we limit it that way.
So if I have a suggestion here, can we just kind of maybe read from the quad tree if the driver location has changed? If not, then we don't have to write anything, right?
So you are saying if we read
Yeah,
the driver.
because I'm thinking, do we keep on sending the location even if it's not changing? I would say yes, because maybe if the location is not changing, we can decrease the frequency of the drivers who are not moving, right?
Yeah, that will be a good optimization. Yeah, absolutely. But still, there will be a lot of movement always, right? So if you look at the idle time.
Hello.
Yeah, go ahead.
I think the GPS signal always changing. So if we want to do that, we have to decide what considered to be not changing, right? Maybe in maybe give a delta of the change. If within the delta consider is not changed, but the GPS signal is always changing, even you are at the same location.
Okay.
Really? Okay.
Yeah.
Because we are connecting to different transmission towers, like why?
The satellites, directly satellites. Yeah, because we move a little bit, then it will change. But even if you look at it, the drivers are always moving because that is what the application is, isn't it? So therefore, we still, even if it says 3 seconds, that is enough time for someone to move.
Can I have a question? Maybe I jump ahead a little bit. So how do we partition a quad tree?
Well, so the way we were thinking and we discussed in the Yelp is we have the quad tree, and at the leaf node, we will have the point of interest, or maybe in this case, the drivers. We'll have only 500 drivers per grid. Okay, at the leaf of that quad tree. And so whenever the driver size increase more than 500 in that particular grid, then we'll have to divide that grid into another 4 children's.
Okay, so back to your diagram, the quad tree is just that blocks. If you go up, that quad tree in the middle, quad tree server, that's a bunch of machines, right? And each machine gonna stores X number of grids. Is that right?
X number of grids. Yep. Yeah, exactly.
All grids.
Yeah. So the grids will be divided. They will be partitioned. Yeah. But then it will store all the grids. Yeah.
But one server gonna store just a smaller number of grids, right? Not all the grids.
Not all the grids. Yeah.
Okay, cool. Yeah. So it's partitioned by grids. And if that's the case, if I ask a nearby driver and I can find a grid, that will be just one server. And then from that grid, from that one server, I can get all the drivers. And the next question is why we need aggregation server. There's nothing to aggregate.
Yeah, see what will happen on the aggregation server, So even if we get it from a grid, so we still have to see if we are going to search in a radius, because first the aggregation server, what will do is pass on the customer's location, and based on that it will go to a particular grid in the quad tree server. So even if you look at if you have to calculate the radius and find out how many drivers are there, so in that case it might cross one grid.
Oh, I see what you mean.
So, okay. Sometimes the other grid might be in other server also, or maybe in the same server. So, but all this data will be given to the aggregation server, and then the aggregation server will actually take this information and do the calculation of based on that radius and find the exactly proximity drivers only, and also he will do some ranking. So it will involve some other processing also, and therefore the aggregation server.
Right. Okay. Cool. That's good. That makes sense because okay. So search range might be bigger than grid. Yeah. Okay. And what's the purpose of a quad tree index?
Well, quad tree index is basically what will happen is it will keep. It's basically a reverse index in this case. So it will have a mapping of the servers with the places, So what server has, because we'll have to store the places also in each and every server. So which server will have the number of places, that will be a mapping, like an hash table in it. And so whenever the whole of the query server fails down, so it will look at the query index server and try to build it again. So that is what the purpose.
Right, but that only applies to Yelp, right? In the case like Yelp, where you have a static locations. But from I think we are talking about Uber right now, or ride sharing, right? So the location data of the drivers are actually ephemeral, right? It's keep changing. So we do not need to store those locations in a static database.
Yeah, but then see, we actually store in this SSD storage for that reasons.
Right.
You know, so the driver locations are stored in the SSD storage, and this driver location server will actually inform the query about the locations. So that whatever is stored in here, so we pull it from the SSD storage. So that persistent storage is here in the SSD storage. So
right.
I get what you're saying. We don't actually store all the driver storage in the database. Okay, but at least I think something will have to store when actually, because when the whole thing fails, right? So you need it to start from somewhere. So therefore, whatever is in the query, because see, the driver location server, it takes the hit about getting all the driver locations per 3 seconds, but it is not passing all the information to the query server. It only passes after every 15 seconds. So that 15 seconds, actually, whatever that information, that is still has to be stored in the database.
I'm not totally buying into that. I mean, 15 seconds, let's say one of the query server machine dies, in this design, it actually requires maximum 15 seconds to get in the data, right, from the drivers at real times. I'm not sure it's worth to store that location data in a database.
Yeah, maybe, but that is what I think about, because then the database is it's storing nothing, right? So it has to store at least the driver location as well as the customers and all that.
I did a little bit of research on this question. I think the database primarily stores some other information like trips. Trip data needs to be durable, right? Location data is ephemeral. What else? And there's some other data is
so like user information, right?
Yeah, the driver information,
user information, trip
yeah.
information,
Maybe.
drivers information.
Yeah,
those data, especially trip, right? It has to be durable and right. And also for the trip, for each trip, the location right? The car is moving to fulfill that trip. That data has to be durable also. But in terms of the driver moving around,
location.
Right.
Yeah. So there is some things it is stored. So in worst case, if everything fails, you know, what will happen is even the query index server fails, it will go to the database and actually completely rebuild the whole query server. Because the query server is the key in this case also, right? So we need to have a fault tolerance mechanism.
But it's good observation that each 3 seconds we will receive a new location from each car. Yeah, we don't need to save query in the database. What's the reason? In 3 seconds we will be able to build it from scratch. No.
Yeah, I think that's kind of what I think in the. You don't need to persist the driver location data except for the trips, but you do need store durably in the quad tree partitioning, like in the what on the grades, right? That entire tree structure, you need to store that.
Yeah, but if you look at the very high level of the overview of the system, we actually need the driver locations also somewhere for analytic purpose, right? I'm just thinking loud, you know. I don't know. But
I mean, that can be like a like a S3 or something. Doesn't have to be like a database that we frequent for requests, right?
Yeah, yeah, I agree. I mean, that location, that thing, for history analysis or trip analysis, that's more like logging side of problem. It's not like this real-time thing, yeah.
No problem. Yeah. So yeah, that's a good thing, and thanks for bringing this. Yeah. So we'll discuss that about how we are going when we are going in this, right? So this is the way, and then what we are saying is we will actually. So now when I'm saying when we only inform after 15 seconds, so what is being done is this the data which we get every 3 seconds, that actually stored in a hash table, and what they call is something like a driver location HT, with the key as a driver ID, and then you'll have if you look at it, these things will be stored on in the driver ID, old latitude, old longitudes, and the new latitude and new longitudes in the hash table. So that will be updated every 3 seconds, and that actually is a part of this location server, driver location server. So all that information will be in the driver location server. So then they are just calculating how much will be that data storage. It will be approximately for 1 million total drivers. It's going to be, because we need at least 35 bytes for that storage, because 3 bytes will be for the driver ID, and rest of them, actually all of them 88 bytes. So it's going to be 35 bytes total. So 35 MB data will be stored in this driver location server. And so then it just talks about the bandwidth for the driver location updates. In that case, whenever the driver is updating his location, he's actually sending his driver ID and the latitude, longitude, which is just 19 bytes. So that comes to around 19 MB per 3 seconds, which is approximately 6.5 MB per second. So that is what the bandwidth of the driver location updates. Okay, so now then what happens about this driver location hash table also will have to be distributed, isn't it? Because that will be many drivers actually sending all this data. So that also has to be replicated, and then we'll have to distribute to, and it will be distributed on multiple servers, and it will be the distribution will be based on the driver ID. And so each driver location server will hold a driver location hash table. So what it will contain in that case is so driver locations will be broadcasted to the interested customers. Okay, so that is what actually will be done from this driver location HT. So one of the requirement here is because when the previous Yelp query is more static, and it doesn't inform if there are quick changes in the driver locations. So how that is done is actually, so the driver location server takes care of it. Whenever there are changes in the driver location, it actually notifies to a notification server, and that in turn informs the customer. Okay, so that actually is taken care of. It's not done by the query server, but it is done by the location and driver location server. So therefore, so
the hash table is on the driver location servers.
Yeah.
Hash table. Okay, got it.
Yeah. So because query server will be storing only the locations after every 15 seconds, but this driver location server will have the very recent data, and it will be more dynamic. And so therefore, whatever the updations will be in the driver location server actually will be sent to the notification server, and that is the way it will be informed to the customer. For the so what it says, when I was going through this design, so the issues with the Yelp squad tree design are active drivers report their location every 3 seconds. So there will be a lot of updates to our quad tree. So that was not possible in the Yelp's design. And second was there was no quick mechanism to let the active customers know of the nearby drivers, isn't it? Because in the Yelp system, we were pulling the information, right? But in this case, we need someone, because the driver locations are changing very rapidly. So we need some other mechanism buy-in, which the customer comes to know about the driver's location very quickly. So to address this issue, they are actually using a driver location server as well as a notification server service here. So that is a difference. And so the query is not burdened by this information and this complexity. Okay. So
yeah, but as an opposite approach, client can pull each 3 seconds, yeah, because we know that location could be changed only in 3 seconds. Can we use just pull instead of push in order to notify client, so in order to notify customer? What do you think?
Yeah, that is right. So the pull, what is being said, yeah, in some cases they are saying pull is much better, that is for sure. But when actually they both decide on a ride, so at that time the location has to be pushed for that particular ride when the ride is going on, because both should have the same location. So that will be one way of doing it. And also I think it might be for the fault tolerance or maybe single point of failure. So then we have information, actually we get it from notified from some other means also. So yeah, so if you look at the other point, what they're saying is efficiently broadcast driver's location. So we could use the push model using a dedicated notification server, like use a PubSub model. And then the customer queries for the nearby drivers before sending the list of drivers. Okay, the server will subscribe. So whenever actually the customer queries for a nearby driver, so the request actually goes to the server. So when the server has the list of the drivers, so the server is going to maintain a list of the driver and the customer also. So each driver will have a list of customers to which he will notify. So that is the way the push model will work. And the list of customer for each driver, so that is updated in the driver location HT, which can be broadcasted to the other customers. So this overall is a push model, but as you said, we could use the pull model also. So that is what actually is discussed at the very end. So efficient way is customer pull information from the server. So customer sends the current location to the server, and the server will send them the list of the nearby drivers. To avoid the number of round trips to the server, customer will query only after 5 seconds. And so this will be a simpler model than the push model. So yeah, so that is one way of doing it. But before going there, they were discussing if we actually do it the push way, so what are the benefits we are going to get, and if we do it the pull way, whether pull is also going to be better. Okay. So, but actually they have not said anywhere because the notification service is always there in this case. Okay, so, but they are not saying that we are going to always use the pull, but the pull will be used only when the customer does a pull. Okay, so customer is going to do a pull request only when he actually starts the application at the start. Okay, and then after that, I don't think so he's really required, because once he selects a driver and when he's on a ride, so he doesn't need to keep on pulling the request from the send a pull request to the server, right? So someone has to inform. So I think that is the reason the notification service comes into picture.
Yeah, but just let's discuss here. When I sit in taxi, yeah. So and if I open the screen of my phone, and it sounds reasonable to use pull because we will moving. Driver will drive me to some direction. Yeah, I certainly know that each my pull request will return new information. Yeah.
Well, yeah. So the way they designed, I think, the pull request will be initially it will go to the query and get all the nearby drivers. So that will be one pull request done. So you'll get all the information. So, but when you register for a particular driver, so you need only that driver to notify you, isn't it? So,
yeah, I'm sorry to interrupt. I kind of agree with Nick. Only times the poll is not effective is you don't know when the data gonna change, right? If there's no new data, you keep polling. That's the load on the server. But in this case, if you're on a trip in a car, you want to see, you still have to see, open the app and see where you are. I know the Uber app provides that functionality. Then you can just poll every 5 seconds or whatever, 3 seconds or 2 seconds to get to know where you are right now. I feel like because that data is keep changing, it's changing. Every poll, it's not wasted if you have to poll, right? So I feel like polling might be my works in this case.
Yeah, and if we use push in this case, what happens if I close my phone? Yeah, if I do not look at, if I close the application, it will still push some information to me. Yeah, but I will not look at these changes. I will. But if we use pull, okay, we know that okay, I am open screen on my phone. Yeah, and we are pulling, and every request will bring new information. Yeah. Yes, thank you.
Okay, yep. So you are saying but that is right. So whenever you open an application, it is surely going to pull. But then you are saying whenever you again on a ride, at that time also you close the app and again you start it, at that time also it's going to send a request to the server, right? So that's going to be pull request again. Yeah.
I don't think that's totally accurate. When you open the app and then you close the app, close the app means you press the home button on the phone or you go to some other app. That socket connection might still there.
Exist? Okay.
Because the app still running in the background. Depends on the policy from the Apple or Google. That might still happen. But I think the point here is that because data is changing, every poll it's not wasted. And building a separate notification infrastructure, WebSocket servers, it's kind of waste. That's kind of what I'm thinking.
Yep. Yeah, but they still have this notification service. So I'm not sure then if we just say rely only on pulling from this. So what does this notification service will be for, right?
I think notification server is purely for the driver's case, not for the like in the rider's case. I think the driver, you still need the notification.
Okay, so you're saying only the driver will be notified by the notification server, or the driver location will be notified to the customer also?
I think the number one notification case for the driver is the trip request. So you still want to be able to, from the server side, to tell the driver, hey, you got this ride request. You want to accept or not, right?
For the next one.
The trip request, that's unpredictable. We don't know when that's going to come, right? So we need a way to notify the drivers as soon as possible. That's why we need a notification layer for the driver's case.
Yeah, and also the customer will be notified that way he has accepted it. Yeah. Okay, makes sense.
What about if user make a ride request and come out from the application, and now when driver arrives, so user get a notification?
Yeah, so then that also it will be from the notification server, no?
So notifications for any notifications, right? Whatever action is happening, is there is a change in state, the notification server is coming into picture. So you're requested, is your request cancelled? Is your request accepted? Has your driver arrived, etc.? Isn't it?
Yeah. So the notification service actually is doing a lot of stuff. It's not only informing about the right acceptance and all that, but whenever even if we close that app, so at that time the notification server is still active, and then it will push. So it is almost a hybrid model, right? Yeah, they are using both of it, and that makes sense because it will give the more reliability on all the information what we are getting. And also I think Uber has a client side information which is stored, and that is also a high thick client, because it also has its own database data store. And even if the whole server everything is down, actually they pick up the trip data from the customer and the driver, it seems. So that is what they do, but that's not discussed over here though. Yeah, that's slightly complex. Okay, so then again what we can do is so if we can repartition of the grids and all that stuff we can do whenever. So what happens whenever we actually, why this point is important here is because whenever we see more numbers of driver coming in a particular grid, so we'll have to repartition the grid. But they are saying that the way we are doing for Yelp, we had a very hard limit of saying only 500 locations, and then we are going to partition it. But in this case, we'll at least keep 10% buffer, and we'll allow the grid to grow by 550 or something number of drivers, and then repartition it. Because there are chances like we might actually, in some cases, we'll have to merge it also because we have a lesser number of drivers in a particular grid. So in that case, we might have to merge. Yeah, sorry, there was a question. Yeah.
Yeah, can we discuss here how many write requests per second is reasonable for one quad-tree? Yeah, if we keep so in worst cases we will have to change two leaf nodes, yeah, because we can our customer can migrate from one leaf node to another, and we have to use walk for one. We have to use two walks, yeah, walk for one node and walk for another node, yeah. It's interesting to understand how many write request is reasonable, yeah. Let's say 1,000 looks reasonable, yeah. 100,000, is it reasonable or not? Yeah.
Well, okay, so the way so for the grid is we actually have the locations of for a driver. So basically the driver itself, right? So if you have 500 drivers in the grid, okay, so that is a limit. So that is what so irrespective of the right requests coming in. So there might be many right requests also, but as long as they are within the range of 500, that is fine. But if you get more than 500, because in the Yelp case, what we are doing, if we had only, even if we had 501, then we used to actually partition the grid. But in this case, we are saying you don't partition it immediately, because here we are not only partitioning, but we want to merge it also. In this,
I'm trying to understand how many write request is reasonable for one quad-tree. Can our let's as we calculated, we have more than 100,000 write requests per second. Yeah, can one quad-tree, I mean, in one host, support these numbers?
No, but 100,000 means there are only 500 drivers, right? So how are there 100,000 requests in one quad-tree?
So we have 500,000 drivers.
You mean that?
No, I mean not in one quad-tree. We don't.
Yeah,
we are
only 500.
Yeah. So I'm Nick. Can you explain that? What's the question?
Do you mean that one quad-tree keeps just 500?
Yes. Yeah.
The lowest
drivers.
grid will have only 500. Yeah.
Yes.
The leaf. Because we are dividing that the load across all of those grids, right? So if the grid is completely empty, and when we get a 500 requests for that particular latitude, longitude, so that grid should accommodate that. That is what I actually understand based on this design.
Okay. I thought we use just one quad-tree to keep all drivers, all information about all drivers. But
no. So we have a hierarchy, right? Quad-tree has a hierarchy like a binary tree, isn't it? So we have instead of two children, we have 4 children here. It's an array tree. but then it keeps on going down, and all the information is only at the leaf. So every leaf will have only 500 drivers at the most. So that is what this repartition of the grid is saying. So what this repartition of the grid means is, if we actually cross the limit of a 500 driver in a leaf, then we'll again repartition them in 4 different childrens. Okay, but then they're saying that you don't repartition immediately, but just keep a buffer of say like 10%, and then so you actually avoid that hysteresis, because or else you immediately partition it, and then next time you come to know that the driver has moved out from this grid and got to some other, because it depends on which area of the city you are. If you are a very downtown, so you will have a lot of movements around, right? So you don't want to have a partition very frequent. So that is the reason you can avoid that by having some buffer. So like the cushion will allow your grid to grow beyond the limit, and it can also decrease the load on your grid partition merging on high traffic grids. So that is one point they discussed here, and I really like that also. Therefore, I thought of mentioning over here. Okay. So then they were talking about the fault tolerance and replications. So for fault tolerance and replication, they are saying we replicate all the servers. Okay. So the primary does, then the secondary takes control. So when we say replication, in the sense, we are replicating the squad tree server also, the aggregation server also, and the driver location server. So all of these are replicated, and they have a follow that master slave or primary secondary model. And so if the secondary dies down, then we have, sorry, the primary dies down, then one of them becomes a secondary, becomes a primary, and then it takes a control. And also the driver locations are stored in the SSD to prevent the data loss, because we could easily store all this driver locations because they are not much, right? It's only 21 MB or something. So that you can easily store in a server, and that is the locations driver location server. But what happens if the server fails? So for that reason, we actually store it in an SSD also, and that actually, because we store it in SSD, it has a very high fast IO. So therefore, we don't have any problems accessing it from SSD. It is not very fast as accessing it from RAM, but it is surely fast from accessing from a magnetic drive. So that is one thing what they are talking about when they are looking for this fault tolerance. And in this case, if the primary or secondary servers die, we can pick up all the data from the persistent storage. So the quad-tree server actually has 2 levels of support. One is the quad-tree server itself, it is partitioned. And then if it fails, if one of the primary fails, then surely a secondary will be a primary in this quad-tree server. But what if the primary and secondary, all of the whole chain fails? In that case, it will go to this quad-tree index server, and then it will build the whole of the tree. And this quad-tree server is also again replicated. So you have this information of this quad-tree index server at 2 places. So, but if both of them fail, in that case, it is going to go to the database, personal storage, and then it will build the whole quad-tree server. So that is what the information is here. But I think in the Uber, what they say, the drivers are also, the client and the driver side is also very intelligent. It also stores its own trip information in the client. And if the whole of the data center or everything fails, and if there is no information, then they really start picking up all the information from the rider and the customer, the driver and the customer. And that is the way they actually build, because they usually, whenever it fails, you still have some snapshot somewhere where it failed. So you need only the delta, whatever is remaining. So that all data will be picked up from the customers and drivers. So that is why what I read from some other sources, but that's not over here. So that is what actually they talk about this one in the fault tolerance. And the secondly, they were talking about the ranking also. So there are different ways we could rank a driver. We can rank a driver based on its proximity and the popularity. So the proximity, actually, we know that whenever we get a request here, actually it goes to the aggregation server, and the aggregation server looks for that information in the query server. Based on the customer's location, it finds a grid, and then it goes to the nearby grids based on the radius, whatever the interest the customer is looking for. And all that information is sent to the aggregation server, but the aggregation server also maintains the query also maintains the driver's information and the rating based on its popularity and all that. So along with the driver location, he also maintains the driver's this one, the rating. And that together will actually pass on to the aggregation server, and the aggregation server has a way to rank those drivers, and based on that ranking, the first 10 or first 50 or first 100 is sent back to the customer. So that is the ranking system what is done over here, and they have given stress on it also because in some cases that is very much required. So the overall rating of the driver is stored in the query as well as in the database, and it searches for top 10 drivers within the radius of each partition, and then the aggregator server determines the top 10 from the above results. Okay. So the other advanced topic about what happens if how do we handle the clients are on slow and disconnecting networks. Okay. So that I said, they actually have some information stored in the client end also, and that is what is actually always synced up with the server. But that is not a topic for discussion over here because it's in a topic itself. And the second about if clients gets disconnected during a ride, how will you handle the billing? So we didn't discuss anything about the billing in this case because that was also not the scope of this discussion. Maybe we can have that for some other time. And the billing itself and all those stuff, it's very huge because the Uber system is a very huge system, right? So we cannot discuss everything here. And how about client pulls all the information instead of server pushing it? That is what Nick was also discussing, right? And so I think whatever they have discussed, they are actually giving both this information, but there might be a way to use this way, just client pulling all the information instead of the server pushing it. But that detail, whatever those design details will be, that was not a part of discussion here. But yeah, that is a good thing. We might actually take up some time later. Okay, if you can add, if you have any points on this.
So this DB will be SQL will follow here, right? Because of ACID compliance we need here also, right? One user should be booked to one cab.
Well, that's a good question.
Like, I mean, I didn't see
DB. We never went in that data model for this. Yeah, because we started basically the whole discussion started with the query from Yelp, and then modify the query from Yelp and how we can use it for the Uber, because it might happen when you are in an interview, you are actually working for a Yelp design, and then if the interviewer asks you how you actually modify this query so it can support the dynamism of that query. So then this is a slightly enhanced topic for just for your discussion, I would say. Okay, but this therefore they have taken just a Uber as an example, but we are really not designing Uber, okay? Because designing Uber in itself is a very big thing.
True. Yeah. It's an overview kind of, yeah.
Yeah, it's an overview or maybe a discussion points for you to actually take away from here. In case if you are just discussing Yelp and then someone asks you about how you can dynamize this whole query, then this is what it is.
Yeah.
Okay.
Can we discuss here if it's reasonable to use message broker server like Kafka before query? I mean, so we have connection between drivers and the driver location server. Yeah. Is it reasonable to use Kafka here? I mean, okay, driver sends his location every 3 seconds. We can just save this message to log, to Kafka log, yeah, and then update. In this case, we will achieve high availability, yeah, because Kafka is high available by default, yeah. And okay, we can have, but for client requests, we, as example, we will not use Kafka, yeah. But maybe, yeah, because I don't know the reason. But can we discuss about this? Is this what do you think about it?
So you're saying this driver location server, basically here in this design, they are just talking about a hash table. Okay, and then the hash table will have the driver ID along with the latitude, longitude of the driver. So instead of that, you are saying we use a Kafka.
Oh, we can have still something like
No, I didn't understand. You are saying Kafka should be here, or where are you looking for?
It should be before Q3 update, something like this. Yeah, and so driver just send messages to log. Yeah, and then subscriber will receive this message and update Q3.
But okay, so in that case, so see the Kafka, the way it works, you will have to subscribe for a topic, right? So in this case, we have a driver ID. Are we going to have a topic for driver ID?
No, just no, not for driver ID, but just topic for incoming messages from drivers. Yeah, it's something like drivers location topic, something like this, which will be partitioned
based
and
on
it
the
will.
quad
Yeah,
tree.
I think that would make sense if the driver location server's request is lost for some reason. It could not reach to quad tree. That's when we could go for maybe something like this. So your message don't get lost or updates to the quad tree. But I think in this case, you would be fine with even, losing these messages because it doesn't need to have like more strongly consistent the quad tree updates.
Yeah, but business will affect, right? I mean, if the request is lost, let's say somebody is booking, right? And if it doesn't reach to the quad tree, I mean,
your second 50 seconds request might get it updated. You could use, but I am saying that is the only case we could go for something like Kafka to not to lose that particular message or update that request from driver location to quad tree. Other than that, I don't think.
Mm.
No.
Yeah. So the way
quad tree purpose is just for the mapping with the rider and the driver, and after mapping that, there is no point that update the quad tree for the driver, because that driver is already engaged in some trip.
So the driver is engaged with for the ride. So actually, the notification server itself is enough in that case, right? So you don't need to actually update the quad tree. You'll have to update only the quad tree when the actually for the new ride.
Yeah, when driver is free.
Yeah, when it's free. Yeah, makes sense. So there might be some different way to, instead of flooding all those quad tree.
I mean, to make the design simple, though, one can argue that if the driver is nearby and about to finish the ride, so if you see that the Uber consider those driver as well.
Yeah, that's a good point. Yeah, so there will be a lot of optimizations, and yeah, sure.
Yeah, so it's better to keep it simple and let's keep only the available driver.
Okay, so only the available driver in the quad tree which are not actually a part of any ride. So that will be a part of the quad tree. So overloading the quad tree is actually reduced in that case also. Okay, that's perfectly good.
Question, like, drivers, even when they're during a ride, they can accept the next ride if they are nearby. And it tells, it tells, multiple, I'm not talking about pool, even if it's individual, they can accept, and then it says your driver is completing another ride. That's what the notification you get. So if we are just doing available drivers, then we are like churning them out.
No, but then we can have a question in that case, right?
Let's keep the design simple and let's actually make it and clearly say to your interviewer that I'm considering only the available driver in this.
Yeah, okay.
But that way, what you are saying, we can actually handle it by saying, okay, we can keep a cushion, saying 20% time before your ride is going to end. So you can have that. At that time, you can start updating the query, something like that. Yeah. Okay.
How will it shard queries more?
Query sharding is based on okay, so in this case, in our Yelp design, it was based on the location ID. Okay, so in this case, this is also going to be based on the driver ID.
It should be location ID here also. Or location will be changing, right?
Yeah, so location, the driver location, right? No, but
Okay,
I know Uday is going to say that. Sorry, go ahead.
No, I'm asking. I don't know.
Yeah, because then it is actually going to be a lot of burden on the query. Understand? Absolutely.
So you are Santosh, you are saying that you will shard on the driver ID. So in that case, each server will have the full query.
Each server will have the full query. Driver location. Sorry. Okay, I my bad. Location ID of the driver. Yeah, based on the location ID. Yeah, it is still going to be the location. Yeah.
Okay. So
one location will have multiple drivers, right?
Yeah. One location will have multiple drivers. Yeah, you will have many drivers. Yes.
Yeah, because many cabs might be going in that direction, right? Or whatever.
Yeah.
Sorry, I did not get. Do we partition by city something like this? This city, this has one quadri, another city has another quadri, something like this?
No. So query actually not the region wise, because if you do it region wise, then what will happen? It's going to actually have that hotspot issues, right? Because if it's some busy street, right? So that grid will be very busy. Yeah, then you say if you do it by the location ID, then it will be the same problem, right?
Yeah, and it's not clear what is the location because we have two coordinates. Yeah, when did you? Yeah, it's not just one.
Right. So then what is the problem sharding it by the driver ID, Praveen? How can the whole query be on a single server? Because then we'll have different driver IDs, no? So they will be sharded accordingly.
You are sharding the driver ID.
One driver is in San Francisco and another driver is in New York, and both may be in the same shard. If you are just sharding based on their ID, is not that possible?
No, so the driver IDs can have ranges, right? Like I will hash the driver IDs and then I can have them in different servers, no? Sorry, I didn't get why will all of them. Sorry.
Based on the range.
Yeah, hash could both fall into the same partition, right? The driver in San Francisco and New York could go into the same server.
So we have to do it by location ID. Yeah, and location ID to the server that will store this. And
I think if it is like a hotspot city like San Francisco, then we could again partition using like consistent hashing or something again internally and then load balance it, like virtual nodes.
Yeah. So exactly the way it is for the
partition we can handle using replicas.
But you will never have more than one city in a query ever, right? Like, so there's no reason to store data from multiple cities in a single query. So you'll always like your initial shard will always be based on either like a sub-region or
the
like
grid,
maybe like the neighborhood, right? Yeah, exactly.
Yeah.
Neighborhoods, right? So you'll always have like, so for a neighborhood of SFO, you'll always have a separate query, right? And you'll never mix data with from New York there, right? Because there's no point in doing that. And
so I'm
that query will only have that. Yeah.
If the postal codes can help us shard based on regions, no?
So you are saying do it start with based on the region
Yes.
And then you keep on partitioning based on the size of the number
And the
of
number
drivers
of
per
drivers,
million.
yeah.
So one thing they would use is, I mean, if you think that S2 or that quad tree also divides it into sub-regions, right? So the geo hash or the S2. So you can actually assign each region with an ID. You can pick the region at the smallest level such that you won't have any hotspots or something. I mean, if you pick a small area such that there won't be too many cars, there won't be any too many hotspots as such.
No, but that granularity would also increase the number of hops, no? Not the number of levels I have to travel to get. So we cannot be very, very small. There has to be a balance there. Yeah.
Yeah, that's what I was saying. So you decide the level on which you can you want to store. I mean, so there are S2 when there's an S2 library which divides the map into some levels. So you give the level, that level decides how much area you will be that cell would be representing. Saying in a similar way, you decide the level such that there won't be too many cars and not too many.
Yes, so I can give you a scenario, right? Even if we, and it's like a edge case, that for example, Olympics are happening and it's some major event is happening in that particular, division that we thought there won't be any time more than these many requests. But suddenly, just because it's a huge event, and it's a hotspot. So there has to be a way to handle those situations as well, right?
Yeah, in that case, you I mean, if you have a smaller regions, it could be possible. I mean, that you are subdividing that hotspot region into smaller regions. I mean, true, but you would have too many metadata, but that is reducing the hotspot ratio as such.
So then the question to the interviewer can be, do we care about such edge cases? If during such an event that happens once in like 4 years or a year, if we have a latency on a service, is it acceptable?
Yeah, but in that case, is it not good to have it based on the location ID? No.
I mean, it has to be based on location ID itself. Otherwise, we cannot have this nearby thing, right?
Okay.
But instead of, but you're translating the location ID to some the geo hash ID or something, some S2 cell ID or something like that.
Cool. The question is that what is that location ID?
$1 million question.
So I think I'm kind of agree with you there that you can transform that let long into geohash, and you can use some sort of a level of that, whether that geohash is level, I think they have up to 9 level.
Well, location ID is something which will be a unique ID with the locations, latitude, longitudes, and everything. So then it will be unique ID.
So you
basically.
Are saying that for each latitude, longitude has a location ID.
Yeah, something like that, right? Yeah. So you see, if you have 500, in this case, we have 500,000 drivers, right? So they will have 500,000 locations. So each of these, whenever that location will have a latitude, longitude, maybe like a older latitude, longitude, and the newer latitude, longitude. So because he just moved in from one place to another. So that whole cell will be one.
That's why actually you need to have, when you're having the quarter server, you need to associate the data with a TTL or something like that. So what Lyft has done is they they have done it a similar way, but they kept the data, the location data of the driver with a TTL as such. So even if the driver is moving between even if the driver is moving between regions, the other the pass cell can with the TTL, that data won't be there.
Yeah, so Lyft, they don't use the quadtree, they just use the Redis and use the I think geohashing to transform the latitude longitude into an ID.
Yeah.
So that is what actually I think the unit ID.
The cell logic I was talking about.
Yeah.
Cool. Okay, so that was a good discussion, and thank you guys for